Okay, rundown. Ideal gas law and where it comes from. Oh, and remember, we're always talking about temperature now in degrees Kelvin. And here's why. First of all, Charles' law, volume is proportional to temperature. What we can do, instead of saying that as a bit of a qualitative relationship, we can make that really direct and mathematical if we add in a constant. That's the letter K. So we can say the volume is equal to temperature when you add in this number, the constant. A constant's a little bit like pi when it comes to circles. It's an unchanging number that allows two things to be described, and it doesn't matter what the circle is, pi will always work. That's the same here, it's K. Now, volume is equal to temperature when you add in that little wiggle number, the constant. Because the constant has been figured out by people who are smarter than me, and it uses the degree Kelvin, it means that we always have to add in temperature with degrees Kelvin, otherwise the units won't cancel and our maths will be wrong. Boyle's law, pressure and volume are inversely proportional. They're the two opposite sides of the same coin, and Boyle's law only works at constant temperature. Gay-Lussac's law is pressure is proportional to temperature, at constant volume and numbers of moles. And Avogadro's law, that the volume is proportional to the number of moles. And that's exactly the one that we used in our depth study if you did if you did magnesium reacting with hydrochloric acid. It doesn't matter what gas it is. It could be hydrogen gas, oxygen, or any of the noble gases. 1 mole of any gas will give you 24.79 litres. It's an incredible property of the number of moles, and that was something discovered by this guy Avogadro. This relationship will only work at standard temperature and pressure, 298 Kelvin and 100 kilopascals. So there are our laws as we have them so far. I'm just going to rearrange the V with the P there, but that's the same law. And here are our others. What I'm going to do is just collect all the V's. I'm going to collect all the little proportional signs, and then I'm just going to collect all my other terms. Just completely arithmetically bringing them all together. And this is where I get rid of my proportional sign by bringing in the gas constant. First step, I'm going to take my P up, rearranging, and my gas constant, which is 8.314, can be stuck straight in there, and that allows me to change my proportional sign to an equal sign. This, ladies and gents, is the ideal gas law. PV equals nRT is something you need to be able to rattle off quite quickly. Even though it's not an important part of our course, it is an important part of chemistry. And it describes how pressure and volume are a function of the number of moles and the temperature, with this gas constant thrown in there in order to make everything, relational. So this equation is probably going to be one that we do a lot of calculations with. And you'll need to remember, I guess, very quick tip, make sure that you cancel your units. So all the units of pressure will need to be in kilopascals, volume will need to be in litres, temperature will need to be in Kelvin, and N, of course, is going to be in numbers of moles. When I say ideal gas law, what is an ideal gas? Well, an ideal gas is one that we imagine that all of the particles are bouncing each other around perfectly elastically, so that there's perfect bouncing around. In reality, it doesn't really happen like that, but it's a really nice approximation and it makes our numbers go nicely. So for an ideal gas, which is an imaginary perfect gas that we like to imagine, this equation will be used for us here in chemistry. Whenever you need to work out the number of moles and they give you pressure and volume, this is the equation you have to use. Whenever you need to figure out the volume and they give you pressure and temperature, this is the equation you need to use. You just rearrange and solve for like terms. Ideal gas law.